One of the things about functions that you can tell if they have inverses or not is if you can take a horizontal line and you can cut the function in more than one spot, it will not have an inverse. So in other words, let's take this horizontal line right here, and you'll notice that if I take this horizontal line, if I put it down here, I can cut this graph in 1 point, 0 points. But if I put it up here, I've cut the graph in 2 spots. If at any point you can take a horizontal line and cut a function in more than one spot, it will not have an inverse, and it will not be 1-to-1. So in this particular problem, number 7, you were asked to graph this or take this and do the horizontal line test. Now if we take this same line and move it down to the next graph, which we had this kind of, number 9 had a kind of a zigzag going on. Now you can see this line is only going to cut it in one spot here, but as soon as you get to here, you cut the graph in 2 spots. Here you've cut it in 3 spots. So this graph does not have an inverse either. Now number 10, however, if you look at number 10, you'll notice that this graph is only going to be cut in one spot. No matter where that line is, that graph only gets cut in one spot. Okay, so this one does have an inverse. And what's really neat to know is that the inverse actually will be around the x equals y axis. Now this is not a very good graph because it's not perfectly square, but you can see that there's the x equals y axis. And if I take this and I flip it around, it would actually cross itself like this and draw something like that. And we're going to see something like that. So that's what that will do. Now if we go on, one of the things that you'll notice is that we have some new notation. F to the -1 of x is really read f inverse, not f to the -1. So when you see f minus 1 of x, you'll know that this means f inverse. Okay, so they ask you to graph f and f inverse in the same coordinate system. So f of x is given this, so we have to graph this one, which I've done. But how do you find the inverse? Well, here's the steps to find the inverse. Rewrite the y instead of f of x. Rewrite this function with y in instead of f of x. That's all. Then you're going to exchange the x and y variables, as I told you before. So the y will come up here and the x will come here. So in this case, this is the rewritten formula or function. Now come down here further and solve for y. Well, in this case, if you multiply both sides by 3 and subtract 6, you'll get y equals 3x minus 6. Finally, put in your f to the -1 of x, or f inverse of x, is equal to 3x minus 6. Now here's the graph of both of them. You'll notice that the original function is the red one. That's the first one that I graphed. And the green one is the inverse. On the calculator it does not do f inverse, so I've graphed them. This happened to be function number 9 and function number 10 that I graphed, so you won't see them as f inverse, but you can see that this very clearly revolves around the x equals y axis. If I drew a line on there right through here, you would find that that would certainly be an inverse. Now problem 16, they want you to check this with the horizontal line test. So I have a horizontal line here. This is very similar to one of the other ones that we did, and you can see the dashed line as it goes down. As I move this down, it's not going to cut this in any more than one spot. So this does pass the horizontal test. So we need to find g inverse. So our first step is to take g and rewrite the function in terms of x and y. So we write, since g was the cubed root of 2x, we write y equals the cubed root of 2x instead of g of x. Then you're going to exchange your x and y's, just like this, and then solve for y. Well, here it is, solve for y. Basically, this equation right here, we cubed both sides. You get 2y equals x cubed, and then y is equal to x cubed divided by 2. Finally, rewrite it as g inverse. So substitute back in g inverse for y and write it as x cubed over 2. Now here's the verification of this. If it's kind of neat because you can see how f11 was the original function, the red one here, and then f12 was my g inverse, and you can see it kind of makes a cool intersection right there, the way it revolves around the x equals y axis.